Hello everybody, welcome back to the next video for CSC314 assembly language. Finally getting a chance to sit down and do this. Those of you who are ambitious, you may have gone to the old videos, and if you've done these first three, you've pretty much done everything we need to try to get done this first week. And this one's only coming out on Friday, so I realize a lot of you may not be getting this till Monday or Tuesday next week, and that's okay, so don't sweat it. But what we're going to cover in this video is just setting up your Linux environment. And actually, I want to take that out. I was going to introduce you guys to this editor called Sublime, but actually it's going to nag us with wanting us to actually purchase it rather than just take it on a trial basis. I had forgotten that Sublime was not strictly free software, so we'll stick with gedit, or if you're already familiar with an editor in Linux, you can pick whatever your favorite editor is. But so we just need to get some stuff installed into our Linux system that we're going to need to be able to actually do our labs. So let's get down to it. Let's see, right now I actually have a clone of our Linux system up and running where I've been testing some things, but we'll bring up the real one, so to speak, and I can do stuff over again while you get to watch. Okay, so from your VirtualBox manager, you should have a saved virtual machine that we created last time, and when you have a machine in a save state, you just hit start to bring it back again. Now you will notice that I have this one called clone-a. There is a way to clone your machines, and I would say use the guided mode unless you're really familiar with how cloning works with VirtualBox if you want to do this. But this is a way you can get basically get a copy of your virtual machine if you want to kind of have a backup or something like that. Want to do some experimenting, but then want to be able to go back to the machine that you had before, that sort of thing. Not a bad idea to use this cloning feature. So something you may want to Google about how to clone machines in VirtualBox and so forth, and maybe learn a little bit about that. So just so that you're aware of that. Now, on to what we're going to be doing. We are going to fire up the machine that we created and saved before. And when it restores, it'll come back to whatever state we left it in, which was, we hadn't really done much with it up to this point, so I think it looks like I just left it waiting for me to log in when I saved it. So we log in, and oh, I guess I had done something. At least I'd opened up a terminal window here. So at any rate, what we're going to do now mainly is set up the software that we need. But I do want to kind of give you a little bit more of an overview of Linux and using Linux. I am going to zoom in this terminal window a bit just so that as you're watching this on a video, it's easier to see what I'm typing. So just real quick, in Linux, of course, you can look at your files and folders through a file explorer type interface, such as what I have right here. You have a home folder. You have various subfolders under there. You can go inside the folders, see what's in there. There are hidden files within Linux, so if you want to be able to see your hidden files, you can choose the show hidden files here and see a lot more stuff. We may actually learn a little bit about what bashrc and .profile, .bashrc, and so forth are, as they could be useful to us. I'm going to try and, through the course, feed you just a little bit of Linux knowledge. Some of you may already be more advanced than anything I'm going to teach you, but maybe there's going to be something here and there that you haven't seen before that I end up sharing. Hopefully you'll all come away from this class not just learning assembly language, but learning more Linux than you knew before. All right, so when we're in a terminal window, we are interacting with a program called a shell. In particular, we're interacting with the bash shell. Let me just put that here in quotes, right? So we're working with the bash shell here. And the bash shell is the program that prints this prompt here and waits for us to type in commands. Then it'll interpret those commands and do whatever it is supposed to do with the commands that we type in. If I just type in random junk, then bash shell comes back and tells me that it could not find that command. Not too surprising that there's not a command named asdf, or however you would pronounce that. Asdf. Okay. So at any rate, we did see at least one command previously, which was the ls command. That lists the contents of your current folder. So I do ls, and notice that this list looks suspiciously similar to the set of folders, the things that were visible. Let's go back to what was visible here. So stop showing hidden files for a moment. And these 8 folders are the same folders that we're seeing listed here, which tells us that we are in our home folder. Another way to see, and if we wanted to actually see what folder we are in, we could use the pwd command. I will say that that refers to path to working directory. So that's where the pwd comes from, path working directory. Again, directory is an older word for folder, much more commonly used back in my day. Today we typically say folder, but Linux still has all the old commands and mnemonics and so forth based on the old terminology. So path to working directory, what we see is that from the root of the file system, which is just /, we go to the home folder, then to the Scott folder under there. Of course, for you, it would be whatever your username is that you created for yourself. And if we look in the File Explorer here, you can see that symbol right there. That basically represents the entire file system of this Linux operating system. And then it has many folders under there, one of which is home, which is where the home folders of users go. You are the only user. I'm the only user on this system. So that's the only home folder that's there. And then we have subfolders under there. So that's 2 new commands you've learned here. What if you wanted to, well, let me point something else out. So bash is giving us this thing on the left, and that's called a command prompt. And command prompt is basically just giving you some basic information that gives you context for who you are and where you are, just in case you forgot who you are, right? So this is just saying that this is a terminal logged in for this user at this machine. So it's machine name and username at machine name, kind of similar to, a little bit similar to an email address. And then we have this symbol right here, which is actually the symbol for your home folder. It's a shortcut symbol for your home folder. So in this case, it's a shortcut symbol for /home/Scott. But you don't have to, but your home folder does not have to be your working folder or your working directory. We can change the working directory of the terminal with the cd command. So if I say cd, and let's say I want to go down into my documents folder, I can say cd documents. And now notice the path here. It's not just tilde, it's tilde/documents telling me where I am. I'm in the documents folder under my home folder. So in other words, the working directory for this terminal is inside this documents folder here, where there is nothing. And I don't even know if there's going to be any hidden files in there. Nope, there's not even any hidden files in there. So that's a completely empty one. And if we do an ls over here in the terminal now, it's listing the contents of the documents folder, and lo and behold, there's nothing in there. Not too surprising. So that's the ls command, that's the pwd command, that's the cd command. What if we wanted to make a folder under the documents folder, say to store projects for this class? Maybe we want to make a folder for called CSC314. Actually, I'm going to stop using uppercase because it's a little bit of a pain. CSC314-projects. Or labs. I generally call things labs in this class, so why don't we stick with that terminology? CSC314 labs. Then press return there. Now if I do an ls, we see that folder shows up here in the list. And if we look over here in our File Explorer view, we see that that folder also shows up there. And now we can cd down into that folder. Change directory, CSC314 labs. And I just did something there which I want to call your attention to. If you're not used to using terminals in Linux, you probably won't guess that you can do this. I'm typing the first couple letters of a file or folder name here, and then if I just hit tab, it auto-completes for me. So that's kind of a handy thing to be aware of. It can save you a lot of typing when you're typing in these commands. So now cd csc314-labs takes me down to the next folder level. So now it is showing me in my prompt, it is showing me where I am. I'm in this folder, and within this folder, within my home folder. If I want the complete path from the root, I can always do the pwd command again, and I get my path here. And so on and so forth. Now let me bring up our class notes real quick. I have provided in our class notes, I'm going to zoom this in a little bit, a subpage for week one, which is Linux Bash Shell Overview. I'm probably not going to try and cover everything I've put in this outline, but these are all things I think that you would do well to just start Googling. Just start Googling Linux Bash. Actually, let me kind of put that at the top. So Google search keywords Linux Bash, and then whatever from below. So you might do Linux Bash ls, Linux Bash pwd, Linux Bash various ask about command options. Just start, find some tutorials, some information. Just start filling in some gaps in your knowledge. This concept of redirecting I/O and the concept of pipes, incredibly useful things to know about in Linux. So I will be kind of feeding some of this to you again in the days and weeks to come as it kind of occurs to me, or as it maybe is helpful with some of what we're doing. But I would really just encourage you to just start Googling and just learning about some of this stuff on your own. Just start becoming a master of Linux if you can. Or at least, try to get to a beginner level of Linux mastery on your own. So let me see if I want to pick out a few more things that I want to talk about here in the video. I know that in your previous 150 and 250 classes, maybe in other classes, you've had, most instructors will have you working in some kind of Linux environment, so most of you will have done at least a little bit of the things I'm touching on here. We've already looked at ls, pwd, makedir, change directory. So I have makedir listed there twice. I don't know why. So there's 3 more here listed that these are very common file manipulations. CP for copy, MV for move. That's kind of the same thing as rename, and RN for remove, i.e. that's the delete command. You want to be very careful with RM in Linux because it's not going to warn you or ask if you're sure you want to delete something, and there are ways that you can delete everything if you really want to, and I would advise against it because that typically makes your Linux system no longer work. So be very careful if you're going to use the RM command on the command line in Linux. In fact, you might want to only delete things through the file view. So if you wanted to delete this folder, you could of course right-click delete, more like you might be used to in Windows or Mac OS. That would be a much safer way to delete things. But, if you want to live dangerously, or if you've saved a backup of your virtual machine, then use the rm command to your heart's content. So coming back over here, and then the cp command, that's for copy, to make copies of files, copies of folders, things like that. And the mv command is actually kind of a rename, okay? You can think of it as either moving a file or a folder to another folder, or you can use it to simply rename it to something else. I don't think I'm going to take time to dive into examples of those, but I encourage you to play around with those on your own. I don't think I'm going to get into those commands just now. Let's talk a little bit about command line options. Almost every command that is available in Bash or in Linux has options to change the behavior of that command. So like we've looked at the ls command for listing the contents of the current folder. Well, there's other things we can do with that. So let's take a look at those. So if I want more information about the files in a folder, first of all, let me actually change directory to my home folder. And the easiest way for me to do that is just to say cd tilde, because tilde is the shortcut for my home folder. So that puts me back in my home folder. Again, if I do an ls here, well, that gives me all the visible folders in my home folder. What if I wanted to see all the invisible stuff as well? All the hidden stuff. Well, if I use the -a option, the A just stands for all, so it basically means list everything that's in this folder. And now we see all these hidden files and some hidden folders. Most of these hidden files are some type of and folders are storing configuration information of one kind or another, and most of this was set up automatically for you just when your user account was created. Some of these are things that you might eventually want to modify, particularly things like bashrc and .profile. So .bashrc and .profile are things that you may eventually want to be playing with. This .bash history file actually is storing a history of the commands that you enter into the terminal, which I might as well show you. That history is then used by the arrow keys. If you just hit up arrow here, which is what I'm doing now. You can hear me tapping the key, the up arrow key and then the down arrow key. What that's doing is it's just going back through the commands I've already entered so that I can re-enter them without typing. And you use Linux enough, you'll find that you often want to re-enter the same command many times. So this is a pretty nice convenience, and it actually stores quite a large history. So, so there's that. And let's see. There's also a way to get more information about the stuff in your folder with the -l option to the ls command. So this is the same ls command, just with a different option, -l. And now we get a vertical list of the things in the folder, and we get all this other information. On the left here, these are permissions, read, write, and execute permissions. Although the execute permission, the X, which normally means this is an executable file, also can mean it's a directory. So these things have that X because they're directories. And there's 3 levels of permissions. That's why we have RW here and we have R here, but not W and so forth. So that's kind of user permissions, your permissions for yourself, some group permissions, and some global permissions. Then we have the owner and group that the thing is associated with. We have a size. We have a time it was created, date and time, and of course we have its name. And you can combine options. For instance, I can say ls-la. And now I'm listing all content, so I'm seeing the hidden stuff, not just the visible stuff. And it also has all this in extra information that the -l option gives. And notice that combining those options, I just string them together after a single dash. And there are other things we can do, like you can do ls, and instead of looking at the current folder, you can look at other folders. Like, what if I want to see everything in the /home folder? Well, there's only my Scott folder in there. Remember, if we back up in the File Explorer here and we go to root, then there's the home folder under root, which for some reason I'm not seeing. There it is. And then there is Scott under home. So if I ls/home, then I'm seeing what's in there. If I say just ls/, then that's going to show me everything under the root folder. So everything here at the root of the file system, we're seeing that same list of things here. If you haven't caught on, then it color codes things. Blue are kind of this dark blue are folders. Off the top of my head, I don't remember what the light blue or the background green with black text specifically refers to. Temp itself is another folder. I think might just be highlighting it specifically because it's a temporary folder. So it's giving it a different color there. But executable files will be in green text, and regular files will be in plain white text, as you can see up here. So you can tell ls to list the contents of other folders other than the folder you're in. We're still currently in our home folder. Like, I can list now the contents of my documents folder. And we have that. And I can combine this with options. Like, I can do ls-l documents. Linux is case sensitive, so if you're completely new to Linux, start to get used to that. Lowercase d, not the same thing as uppercase d. That would be a completely different file or folder name if it existed at all. But of course it says can't find it because it doesn't exist. So if I want to see ls-l documents, then we get the -l form of the list, and there we see the CS314 labs subfolder that we created in there. So let's go ahead and cd back down into documents. And that folder could be for our labs, but what about classwork? Maybe we should have another folder for classwork. So let's do another mkdir here and say CSC314-class or classwork. And now let's cd down into that one, and that's where we'll create some examples and so forth. So now if I hit tab, if I type just a couple letters and hit tab, it's only going to autocomplete until it can't figure out which one I want, and then I have to type a little bit more, hit tab again, and then it autocompletes the rest of it. So that way I don't have to type all that out or remember the exact spelling all the time. And now if I do an ls there, of course, that is empty. If we go back down into my home folder and into documents, then there's our two folders that we've created. If we go into here, of course, it is empty. All right, let's jump back to the notes and see if there's any little things I want to point out just now. I think that's enough, kind of just quick getting our feet wet in Linux for now. So now let's actually move on to what we need to do specifically for the class. So back on the week 1 page, we're going to set up your assembly development environment. To do this, we're going to be installing quite a few packages. And if you're not already familiar with packages in Linux or things like the apt-get command, I would suggest Googling about these things and learning a little bit more, getting a better understanding other than just doing the commands that I tell you to do. I'm going to give you a little overview right now. So Linux, as I'm sure you're aware, is open source free software, and along with Linux there are many software packages for just about anything you might want to do. You know, all the commercial applications, there's various public domain open source projects out there that are just about as good as any of the commercially produced software. And when you consider the price, the value is perfect. Most of those things, particularly in an Ubuntu-derived Linux operating system and many other Linux operating variants as well, give you a pretty easy way to download and install those packages. As long as you know what the package name is, it's pretty easy to do. And that's through this command called apt-get. And there's variations of this command that you may see apt by itself, or aptitude spelled out. Basically, they all work the same way. I'm using apt-get here. It's kind of neither here nor there. I think apt-get is a little bit of the old way to do it, but I'm old, so I'm allowed. At any rate, that's the command that manages these software packages for you. But because that's an administrative task, what we're going to do is we're going to use the sudo command before any command that is sort of administrative. So what is the sudo command? Sudo or sudo or super user do is what that stands for. Basically is a command that says do the command that comes after this as the super user. Okay, you are the administrator on your machine, but unless you put sudo in front of a command, it's not going to give administrative permissions to the command that you're trying to run. So we want these commands for installing software to be run as administrators. So we put the sudo first, then we put the command that changes software, reconfigures the system, whatever, that kind of thing. So if you start learning about Linux and start doing more administrating your own Linux systems, you're going to run into sudo a lot anytime you have to do some administrative level tasks. So that's what we're going to do here. And the first thing we want to do is tell apt-get to update itself with the latest information about what packages are available. That's basically what this first command does. You can actually just copy and paste this into your virtual machine. But to paste into a terminal, unfortunately, Control-V does not work. But you can right-click and just say paste. You can also do Control-Shift-V, which you might not be used to doing, but that's what works in a terminal. So I just did Control-Shift-V there. In case you're not quite hearing what I'm saying, Control-Shift-V to paste into terminal. Got it? Okay, so that's what I'm going to do here. Control-Shift-V. Or, again, if you don't remember Control-Shift-V, you can always right-click, paste. Whichever way you like to do. So sudo apt-get update. Let's run that. It's going to ask for my password. Since I'm the administrator on my machine, that's the password it's asking for. And there we go. Now this won't actually make any real changes on your machine. This is just updating the information that the apt-get command has available to know what packages are out there, what the latest versions of software are, and all that sort of thing. All right, so once we've done the update like that, now let's start installing the things we need. So if we go back over to the notes I have here for you, again, you can just copy and paste these commands. One of the things we're going to need is the NASM, N-A-S-M assembler. That's the one we're going to be using for this class. So I'm going to copy that, go back over to my virtual machine, and paste that in there. So let's install the assembler. An assembler is like a compiler for assembly language programs. So where for C programming, for example, you used GCC to compile your programs, most likely. Here we're going to be using NASM to build our assembly language programs. All right, with that out of the way, let's jump back over to the notes and take care of the next thing. So I've added just these other things here. This is just some commentary that I added in the notes, and I just explained what super user do was, so you already know that. Let's see, we also need to have a text editor. Now there are text editors already built in you might want to use. There's Nano. Some of you in your previous classes may have used Nano. I'm not particularly a Nano fan, so I'm just going to exit back out of there. Maybe some of you used VI, and if you like VI and want to keep working with it, that's great. You can do that. Whoops. There we go. Exit out of VI. The default text editor that comes with Linux Mint is Xed. And I think that's a little bit too simple of an editor. Actually, I shouldn't say I don't know that for sure. I just have never used Xed myself, so I think it's recently been added to Linux Mint. At any rate, I'm not terribly familiar with it, so I'm going to steer you towards a program called gedit. So let's do sudo apt-get install and gedit. And I guess I didn't really explain all the parts of this command. So you know what sudo is, you know apt-get is the package manager command. Install is just a keyword to tell apt-get that you want to install a package, and then nasm, that is the package you wanted to install. So that got us the assembler. This is going to get us the gedit software. And here it's asking, do we really want to install it? And we want to say yes. And now gedit is installed. So now if you type, for example, gedit on the command line here, you get a text editor. So we might as well, let's go ahead and create a text file. Here is some stuff and some more stuff. So much stuff. All right, great text file. You do not have to do the same text as what I just did, but go ahead and use gedit, create a text file, and do a save as, and let's just, I'm going to call it some stuff.txt. Why not? So there we went, and now what I'd like to do is come back here and do an ls command and have it show me the file that I just created. But I can't do an ls command right now. Notice that it has not come back with a prompt for the next command yet. That's because it's waiting for the gedit command to finish. So for now, I want you to exit gedit, and I'm going to show you another little Linux tidbit. So we're going to quit. And now because gedit finished, now the command prompt came back and is ready for another command. Now something like an editor like gedit, you really don't want to have it tying up your terminal like that, right? So make sure you note the next thing I'm going to do here. Gedit, and I'm going to put an ampersand at the end of the command. The ampersand is actually part of something that the bash shell, okay, the shell program that is interpreting the commands that we're entering in, knows that if you do an ampersand at the end of the command, that means you want to disconnect the running of that command from the terminal. So if we do it this way, gedit pops up its window again, and we get the command prompt back here. And what it is showing us here, this is the real result of using the ampersand. It's basically kind of giving a process number or a background process number for, okay, we have this process detached, and it's arbitrarily calling it process 1. This is actually this is sort of a system process number associated with that. This is not terribly important. It's just so it's not just sitting there in a mystery, complete mystery to you. So now gedit is running independently of the terminal. Okay, and that is all because we just put this ampersand at the end here. So from here we could open, or we could actually do open recent. Actually, it's not remembering the file name for some reason, so we'll just do open and find our some stuff.txt file again, and there it is. We can edit it again if we want. And again, when you look in the File Explorer view, there you go. There's some stuff.txt inside CS314 classwork, inside documents, inside home folder, right? So just to make sure you're fully oriented, because I'm sure that at least a few of you have perhaps not dealt with command line interface like we're doing here. And I just want to make sure that you keep making the connection between what you are more visually familiar with to what is new. Apologies to those for whom this is all very familiar. You might want to be skipping ahead a little bit, but you never know what kind of tidbit I'm going to throw in here that is new to you, so it doesn't hurt to kind of have what you already know reinforced. All right, so that's gedit, and we'll leave that for now and go on. But now I can do an ls command, and we can see some stuff.txt listed here. And I said I wasn't going to do the other commands, but let's go ahead and make a copy of that just for fun. cp some stuff.txt, and we'll call it some other stuff.txt. That's going to make a copy of one to the other. And so now you can see both of them, and we can bring the some other stuff. We can open that here in gedit if we want. There's the some other stuff.txt file. So now we have both of them to mess around with. We can edit them, make them different instead of being identical. So that's the cp command. And I'm not going to do the mv and the rm command, though. I'm going to avoid going down too many tangents. All right, so what do we want to do next? We want to come back to the notes and install the next thing. So we've got NASM, we've got gedit. Bless is another editor that we need. We don't need it right away, but you might as well get it installed. And since it's listed in this order in my notes, I'm going to do it. So let's copy that, paste over here. Pasted the wrong stuff. Oh, I don't need to copy and paste. Sudo apt get install bless. What is bless? Bless is a hex editor. If you've never used a hex editor before, it's basically going to give us a way to look at binary files, such as executable files, and actually see the binary or hexadecimal codes that make up those files. Just to give you a little taste, let's go ahead and run bless on one of our stuff files. Bless. Let's run it on some other stuff.txt. And I did not do that with an ampersand, so it's going to tie up my terminal. So much like gedit, notice I'm not getting a command prompt here because I did not use ampersand at the end of this command. And also, bless prints out a whole bunch of extra messages that kind of clutter up your terminal. Just be aware that it does that. It's not really hurting anything, but you might not like the visual clutter. You might want to open a second terminal to run your bless command from, just so it doesn't clutter up the terminal that you're doing your main work in. But here's the bless editor, and let me make it a bit bigger. Let me see if the view or preferences, because I'd rather you be able to no, it doesn't have a lot of preferences, so I can't make this bigger. So I apologize there. So when you're watching this in video, I don't think it's it's not going to be too terribly unreadable if you have your video full screen. And you might have to get a little closer just to be sure you're reading this clearly. But so here is the text of that file, as you would perceive it as text. All right. Here are the bytes that make up that text. Hopefully most of you have learned about the ASCII code in your previous courses, in your 150 or 250 courses. If not, let me give you a quick rundown. Every character, such as a capital H or a lowercase e or a period, or even things like the new line character at the end of a line, those all have what's called an ASCII code, which require what's called 1 byte. Hopefully you've learned about bits and bytes, but if not, we're talking about bytes. A byte is basically a number from 0 to 255, but it comes from binary. It's made up of 8 binary digits. We're going to be getting into that in a bit more detail later on, so I just want you to get a feel for what bless is showing you here. So the H has, in the hexadecimal notation, the byte, the ASCII code for H is a 48. That actually means 4 times 16 plus 8, so that's actually, in our normal decimal notation, that's a 72, which you can see right down here where it's showing both the signed, the unsigned 8-bit is probably the one you want to look at most if you want to look at it as a decimal number. some of these other things that it's showing us here, these are actually numerical interpretations of more bytes than what is shown. Like the signed 16-bit and unsigned 16-bit numerical interpretation, that's actually interpreting 2 bytes at a time. So if we take those 2 bytes together and interpret them as a number, it's this number. Or we might want to be interpreting 4 bytes at a time, then it's this number, and so forth. For now, just the main thing I want you to get a feel for is, okay, each byte corresponds to an ASCII code, corresponds to a letter of text in a plain text file. If we go up here to this first period, so whoops, let's go to that one. So we see 2E, so that would be 2 times 16 is 32, E is 15, so that's, if I did it right in my head there, that's a 47. Nope, it's 46. E is 14. F is 15. So 46. And the ASCII code 46 represents a period. But what about this OA, the 0A? Well, in hexadecimal, that's a 10. And we can see down here, 10. So that byte is a 10. That's the ASCII code for the new line character. So if we go back and look at this in gedit, after we typed a period, I pressed the enter key, which means drop to the beginning of the next line. Well, there's an actual code in the file that represents that. That's what that 0A is. That's actually, and again, that's actually a 10. So there's the 10, and so on. So we're going to be using the Bless editor just to get a better feel for when you actually compile a program and it creates a binary executable file. We'll actually go into that binary file and we'll see kind of the relationship between your assembly language commands and the actual binary codes that make up your program, and kind of see kind of the one-to-one correlation between those things. But that's something for next week or maybe the week after that before we dig into that too much. But I just wanted you to be aware of the Bless editor. It gives you a way of looking at binary files, binary data. Of course, all files are actually binary. So even if something is a text file, under the hood, all that text is represented by binary numbers. All right, so that's the Bless editor. And now let's do the next thing in the notes. And the next thing in the notes is getting the standard dev tools so that we can, this would actually be so we could do everything we would want to do even just with GCC. We will be using GCC sometimes for some tasks later on in the course. And to make sure we have everything we need there, we want build essential. That's the name of the package. So the complete command is sudo apt-get install build essential. So Control C and come over to my Linux machine and put that command in, and let's install build essential package. And that will basically make sure that we have all the right libraries that we need later on. So we're not there, I don't have anything specific to show you for that. And then last, we're going to be building 32-bit binary programs. So our executables are going to be 32-bit applications, not 64-bit applications. And in order to make sure we have everything we need for that, because we're on a 64-bit version of Linux, we want it to, if we were on the 32-bit version, we would have all this stuff by default. But because we're on the 64-bit version, we need to install some extra libraries that have all the 32-bit versions of things. And so that command should do that. So we want the package ia32-libs, and let's install that. And this one's a little bit bigger, so it's taking a little longer. Don't remember it taking this long last time I did this, but we can wait it out. I suppose you could skip forward in the video a little bit, but you're just going to have to wait for yours to finish too, and yours is probably going to take about the same amount of time. So we can just hang out here and wait together. And actually, once this is done, that's just about everything I want to show you in this video, and then I'll start up another video where we just dive into creating your first assembly language program. So that way we have the topics broken up a bit, and each video is focused. That's one thing. If you do watch the old videos, the archive from last year, because those are each 1 hour lectures, it's whatever we covered in that particular hour. One nice thing, I don't have a lecture class, a classroom version of this class this year, so I get to create the videos, each more focused on a specific topic. This is taking a lot longer than I remember taking before, though. Interesting. Down there on the lower right, I think that's trying to give us an estimate of how much time is left. That makes sense, and it says it's 95% done and there's only 10 seconds left. So yeah, that's giving us a countdown of its estimated time remaining. So it looks like we're about finished. And there we go. Maybe the last time I did it, I was on the campus network, which is a lot faster than my home network. That might be why this is going slower than I remembered. All right, and there it is. So that gets us the 32-bit libraries installed. So I think I'm going to stop this video because that gets us all set up. And then what we will do is I'll do the next video, which actually steps us through creating the first assembly language program, and that'll wrap it up for the first week worth of videos. And again, remember, I realize I'm not getting these videos out until Friday, so really this kind of, as far as expecting when you get this done, pushes into next week a little bit, which is okay. So for now, I'm signing off.